All right, Chapter 11. Chapter 11 is Pesticide Application Procedures. And we're going to get into the different kinds of pesticide applications, as well as some various things to take into account while doing them. So let's dive right on in. Okay, application methods. What are those? Application method is basically how you're going to apply the pesticide. The application method that is chosen directly depends on the nature, habitats, and characteristics of your pest. I would also add that it's going to be based on timing. Certain pests are more susceptible at certain times in their life cycles, life stages, and so you're going to base what type of method you're going to use and also what type of product you're going to use on those things. That's a good IPM strategy. You know, it doesn't make sense to go after something when it's in an egg stage, when it's not susceptible to the product that you're going to use. You might want to wait till it's a larva, and then you can properly take care of it. And probably something that's less toxic. It's also going to depend on the site of the application, the pesticide properties, the equipment that's needed, cost and efficiency, and also alternative methods that could be used. So going back to the previous chapter, you know, talking about professionalism, being a consultant, you might, recommend, hey, we can control this in a different manner other than using pesticides. So it's always something to keep in the front of your mind. All right. So this, if you're listening, what we're looking at right now is a lot of different types of pesticide applications. Okay. They're all kind of self-explanatory, but I'll go over them. So a band application is when you're making even bands of application of pesticide to the ground or to plants. Think of, if you're doing lawn applications, you're making stripes with it, you're making bands. Now that could also be a different kind, and we'll get into that too. Also farms, right? You're making a swath or a band through a field. A basal application is basically applying pesticides on trunks of trees or shrubs. It can be used for both herbicide applications or insecticide applications. Then you have a broadcast application. That's primarily used with like a granule where you're just flinging it out everywhere and it's broadcasting it, right? There's also the crack and crevice application. That's going to be more of your structural pests that are doing this. You're just applying to a crack, and that's where the pest is going to come into contact with it and die. There's a directed spray application, right? Kind of more specific. I guess that could pretty much be interchanged with a spot treatment, in my opinion, but you're more pinpoint targeting. And then we have foliar application. Foliar applications when you're applying it to plant foliage. So if you're doing a band application and you're applying it to a lawn, you're also doing a foliar application at the same time. Same thing with farmers. If they're applying something over their crops, they're doing a band application as well as a foliar application. A rope, wick, or wiper application. That's when you're going to have a rope or a wick, some sort of material that contains pesticide, and it's going to brush up against certain weeds and kill them. It can be used in agricultural purposes. So you have a boom that has a wick that contains pesticides and weeds are growing above your crops. You can drive over them. It'll brush up against these weeds, kill the weeds, and not damage the crops. It can also be used in landscape beds. If you have grasses or weeds that are growing through sensitive ground covers, you can also use the wick treatment and treat just what's growing through it, and it'll eventually die without harming what's below it. We also have a soil application. Soil applications are like a soil drench, basically mainly used with insecticides, but you're going to apply the insecticide down into the soil for it to be absorbed into the plant material. We also have soil incorporation. This is where my experience in nursery mixed in bifenthrin, which is an insecticide. They mixed it into their soil that they were planting in, and it's to kill insects, within the soil. Soil injection, similar to a soil application, but this is you're using a special tool that injects into the ground. It's typically a probe that drives into the ground 6 inches, 6 to 10 inches, and it has the spike has 4 little nozzles, and when you pull the trigger, it shoots out at high pressures out of the 4-way nozzle, decompacts the soil, and spreads out the fertilizer or insecticide or fungicide that you're trying to get into the ground. There's also the space treatment. You're treating a large space, large area. Spot treatments, that's when you're going through and nitpicking, only treating certain locations. And then we have tree injection. That's where you actually put some sort of orifice into a tree, into the cambium layer, and you inject a product right into the vascular system of the tree so it can be carried out throughout the tree. So I definitely recommend that you guys look at this, listen to this again if you need to, and then you'll have a better understanding of what type of applications there are. Guaranteed you're going to be tested on these. Maybe not all of them, but definitely some of them. So what are some safety systems? Well, there's a couple of systems for mixing and loading. These systems are closed systems, and they're designed to prevent contact with the pesticide handler. Some products require closed mixing systems. And what that basically means is that you do not touch it. Basically, the container, whatever's inside the container, the product, the pesticide that you're using, it's connected to a device that's going to inject it into your mix tank, and you never touch it. You're never exposed to it. I would imagine that's going to be some pretty toxic stuff. So more than likely, you're not going to run into it, but some of you might. So just be aware of that. There's 2 types of closed systems, mechanical or water-soluble packaging. The one that I was just talking about was probably a mechanical style. You might run into water-soluble packaging. It's really easy for applicators. You're running like a 200-300 gallon skid tank. You're going to have your product in a water-soluble bag, throw it in, it's going to dilute, and then you're going to be good to go. What are some mechanical systems? It's commonly a series of equipment that's interconnected, and it uses gravity or suction. Again, it's a closed system that's going to seal itself and inject the tank into the carrier. It minimizes exposure from transferring concentrate or rinsate to application equipment. It's more common with mini bulk containers. So those are like 100-gallon to 500-gallon tanks. And you typically have meters for accurate measurements because you don't want to over apply or under apply because you might not get the results that you want. So let's talk about some water-soluble packaging. It's simple to mix and load systems. It's pre-measured out, which is really nice. Very few manufacturers make water-soluble bags for small volume applications. So water-soluble bags are generally not designed to be used in like a backpack sprayer. They're more or less designed to be used in skids. You're probably talking 50 to 100 gallons is probably what they're going to be basing on. If you think your typical lawn care company or plant healthcare company, they generally have a 200 to 300 gallon skid. So they just throw 2 or 3 of the water soluble bags in and they're good to go for the day. It does take a little bit of extra time for the bags to dissolve. So you do have to account for that. But as far as the extra time versus the safety factor for the applicators, it's definitely worth it. All right, so this is more for the agriculture side of things. We're going to talk about some enclosed cabs. Enclosed cabs prevent and reduce pesticide exposure. It's not just farmers and tractors, but you could think tractors, cockpits of planes if you're doing aerial applications, or vehicle cabs. So I do know that some people do right-of-way applications down the road, down our highways, and they could be inside the cab of a vehicle spraying outside, and they'll be relatively protected from that. Same thing with mosquito applications. You have guys driving around with foggers in the bed of the truck, and they're in the cab, so they're pretty safe inside there. It is considered supplemental PPE and not necessarily a replacement. However, some labels may allow exceptions to the rules. So if you're in a cab, they might say you don't need to wear this. Remember, outside of the application equipment, you can have a residue, and it should be considered contaminated until cleaned. So if you're doing any sort of applications where it could drift onto the cab or the cockpit, if you're in an aerial situation, you definitely want to spray that off, or if you do touch it, just know that you need to wash your hands. So let's talk about pesticide containment systems. There's pesticide containment pads for mixing and loading. We have our equipment that we use day in and day out, and containers. And we want to store those areas that can contain any sort of spill, leak, or overflow. Pesticide containment systems help prevent environmental contamination. They're generally made of an impermeable material. They can be equipped with recovery for cleaning. So you might have a little drain that goes down into a tank, and you could, siphon that out or suction that out, and you can recover what might be lost. Smaller pads could be used on site for mixing and loading. I'll tell you, in my business, we do use plastic pads in tailgates, and that's how we mix. That's our containment. So that way, if one of our product jugs was to fall over, it would be contained within that pad, and it would allow us to clean up a lot easier. So application equipment, we have sprayers, which accounts for 90% of all pesticides. Not sprayers particularly, but 90% of all pesticides are formulated to be sprayed. So a lot more spraying than granules out there. We have hydraulic sprayers, uses water or other carriers. Think large volume agricultural sprayers, small handheld sprayers, backpack sprayers. There's also ultra low volume. Ultra low volume is applied directly as formulated or with reduced carrier volumes. We have manual sprayers, think hand cans, a couple gallon hand pump sprayer or backpack sprayers. They're mainly designed for spot treatments. We have air blast systems, mist sprayers. They utilize both air and water as carriers. They're typically used more for insect and disease control. You'll find them in orchards, vegetable gardens, Christmas tree farms, greenhouses, and then also mosquito control. So let's talk about some components of sprayers. First of all, we have the tank. And when you're doing applications, you need to choose the right size for your intended needs. You generally are going to purchase that of a non-corrosive material. It could be poly, it could be fiberglass. Those are pretty much the top materials that are used today. Then we have pumps. Those produce the flow out of the application equipment. They can also feed agitation back into the tank, and they must be corrosion and abrasion resistant. There's a lot of different kinds of pumps, a lot of different types of diaphragms and how they work. There's roller pumps, diaphragm pumps, a lot of different kinds. And they all have pluses and minuses. Some are easily rebuildable, some are not. So we need to choose the right pump. Nozzles, they can control the amount of pesticide applied, the droplet formation, how it's distributed, and the pattern, the spray pattern itself. There's a huge variety of different types of nozzles, and they can vary in different types of materials. And remember, larger droplets are most likely to minimize drift. Small droplets maximize drift. So it all depends on your conditions and what you need. The desired nozzle depends on the target, the application method, and the drift potential. And also, you want to determine the wear and tear. If you buy stainless nozzles or bronze nozzles, those are more abrasion resistant if you're using an abrasive product. Plastic nozzles, they wear out a little bit more because if you're using an abrasive material, it'll slowly chip away at that plastic and change your calibration. Then we have granular applications. Band or broadcast application methods, kind of interchangeable there. They're typically gravity fed. So if you think of your walk behind Scott's fertilized spreader, you put the granule in top and it feeds down and then it spits it out everywhere, or it drops it. They're adjustable as far as opening and regulating the flow, how much is being dispersed. They can use tubes or deflectors, and that's kind of how it flings out material. And there's two different kinds. There's rotary and drop. Rotary is, I would say, a very common one. Most ride-on spreaders are going to be rotary, And it's basically something that spins. So as gravity's feeding those granules down onto this rotating disc, it's going to fling it out. But a drop style spreader is basically you open up a floodgate and it drops straight down. Drop spreaders are more ideal for precise applications versus rotary, because rotary's flinging it out everywhere. It's not very precise. It's more of a broadcast application. Then we have other types of application equipment. We could have rubs or walk-through sprayers. Think of, like decontamination type stuff. You could walk through a sprayer and become decontaminated. There's baits and dispensers. So ants or rodents, we might use baits in that situation. There's foggers, which can be used in outdoor applications for mosquitoes, can be used in indoor applications for insects. There's chemigation, which is using irrigation and chemicals. And then there's dusters. You're applying a dust. I know one off the top of my head is, I believe it's called Delta dust. And it's mainly used in wasp and bee applications. So let's talk about equipment calibration. Calibration is the process of measuring, adjusting the amount of pesticide your application equipment applies or delivers to a specific area. You want to apply the correct amount and material uniformly. You don't want to have, an excess amount on one side and not enough product on the other. That's how you're going to have a bad result. A majority of equipment is adjustable, and some include charts to assist us as applicators to properly adjust the settings and get it dialed in. You want to calibrate your equipment frequently to ensure proper application. Frequently really depends on how many applications you're doing. Once a week, I think, is a pretty good habit to be in, but it really all depends on how much you're using your equipment. Some guys, they might calibrate their equipment once a year and then it's good to go. But you want to be aware, right? Your nozzles wear out, things change. Your pumps might slow down and the rate stops or slows down. If you're using boom sprayers, nozzles can slow down or it could get clogged up. You want to pay attention to your equipment. And then the application rate is determined by travel speed, nozzle size, and pressure. Okay, all of those will dictate the application rate. So how do we calibrate? Well, you want to do a trial run over a pre-measured area, and you want to measure the output. So the rule of thumb that I've always been taught and known is to use 1,000 square feet, mainly for backpack applications, or if you're doing walking applications, spraying into lawns, or even if you're on a ride-on sprayer, do 1,000 square feet, and then you'll know how much is coming out. When you calibrate booms, calibrating booms is generally measured in 1,000 square feet or acres. The nozzle flow rate and the ground speed, the width of the spray pattern per nozzle is going to affect the application rate. And then remember, doubling your ground speed reduces gallons used by 50%, which is huge. That's a massive amount. But that can also greatly affect your application. So even though you can say, I can just do this faster and go faster, you might be not doing the application to the fullest that you should be. Proper calibration reduces costs and increases efficiency and safety. All right. So if you are just listening to this, right now we are looking at a slide, and I took this out of the National Core book, but it is calculating area. And I guarantee you will be tested on calculating area. And there's 3 different shapes to calculate area. There's squares, triangles, and circles. And so to calculate area in squares, it's length times width. That is the area. And if you have to convert something, which we'll do an example, you're going to have to convert it by that measurement. So in this example that they give us, we have an area that's 1,320 feet long and 120 feet wide. So how do we calculate the area? We multiply that. So 1,320 times 120 equals 158,400 square feet. Now, if we were told that we need to make an application based in acres, well, how do we convert it? Okay, so that way we know. Or how do we convert it to where we know the acreage of the area? Well, an acre is 43,560 square feet. So we would take our number that we got for the area in square feet and we would divide it by that number. So we have 158,400 square feet divided by 43,560 square feet, which comes out to 3.6 acres. And then how do we calculate area of a triangle? Okay. You calculate the area of the triangle by base times height divided by 2. So in this example, we have a triangle that has 150-foot height, a 325-foot base. So we take 325 times 150, and we divide that by 2, and we get 24,375 square feet. Now, if we want to convert that into acres, it's still the same thing. We take that 24,375 square feet, and we divide it by 43,560 square feet. And we come up with 0.6 acres. Now for circles, how do we calculate that? Well, a circle in determining the area is pi times radius squared. So this gives us 3.14 as pi because it's a constant, and then radius squared. So we would do, let's see here. This example shows us a 90-foot diameter circle, which means the radius is 45 feet. So we're going to do 3.14 times 45 squared, and we get 6,358.5 square feet. Now, if we wanted to convert that into acres, it's the exact same thing. We take our number that we got and we divide it by the acre number. So 6,358.5 square feet divided by 43,560 square feet equals 0.15 acres. Okay? You're definitely going to be tested on knowing your areas. So definitely run some calculations and practice this for your rectangles, your triangles, and your circles. Now, how do we calculate our application rate? Okay, so again, this is one of those things I took out of the National Core book, and you're going to have a question that has this same procedure on it that you're going to have to work through, and then you're going to have to find the answer. So in this example, we've determined that our boom sprayer delivered 10 gallons of water over a 1/4 acre, so 0.25 acres in our test area. And you know that you need to apply a pesticide product to a 10-acre field. Remember, an acre is 43,560 feet. That's 1 acre. The pesticide label recommends 4 ounces of liquid product be added to give a desired finished spray mixture of 1 gallon. There are 128 fluid ounces in a gallon. How much spray volume and how much product are needed? So the first step is how much spray mixture is needed for a 10-acre application. We need to figure this out first. Always use information from the calibration test. In this example, 10 gallons covered 0.25 acres. So we do 10 acres multiplied by 10 gallons divided by a 1/4 acre, or 0.25, and we get 400 gallons is required of spray mixture. So now we have to determine how much product we need. Okay, so we know that we have 400 gallons that we need to apply for that 10 acres. So we take 400 gallons, which is the spray mixture, and we multiply that by 4 ounces of product. Because remember, it's recommended at 4 ounces of liquid per gallon. Okay, we come out to 1,600 ounces or 1,600 ounces of product needed. Now, how do we convert that to gallons? Well, you divide it by what is a gallon? A gallon is 128 fluid ounces. So 1,600 ounces of product divided by 128 ounces comes out to 12.5 gallons. And now you've figured out the application rate. That's simple, super easy. It's just cross multiplication and then understanding your multiplication and division. So I highly recommend that you work through this, look at the applicator manual or look at the notes, and you'll be much better off. You're definitely 100% you're going to have a question on this on the exam, if not multiple, because they want to know that you know how to properly calculate the application rate. All right, so let's talk about some techniques to minimize drift. I think we've touched on this previously, but with this being the last chapter, the book really wanted to drive it home, so we're going to go into it. You want to follow the label instructions and specifications to reduce drift. First and foremost, the label will tell you if it's really prone to drift or what to use, if there's any specific additive. You want to select a nozzle that increases the droplet size. Remember, increasing the nozzle size increases application volume, so you'll be putting down more material. You want to stay up to date on newest technologies. There might be some new products out there or new application equipment that can reduce drift. If you're using a boom, you want to lower the boom height as close as you can, so that way it's closer to the ground, which would minimize drift. You want to maintain an appropriate speed. If you're hauling ass driving down the road or in a field or on the yard, you could have more chances of drift and not a very good application. Keep the nozzle close to the target. Similar to lowering the boom height, if you're using a backpack sprayer or whatever, keep it close. Avoid high speeds. Avoid applying during high winds. Pretty self-explanatory there. If there's high winds, it's very likely that it could carry a product far, far away. So you need to know when to hold them and when to fold them. Do not spray during inversions. How do we determine inversion? You could measure the temperature of the ground and then also above ground, basically where you're standing at arm's length, and see if there's a big difference. If the ground's colder, then there's an inversion. You could also use smoke. If smoke is lingering around and traveling laterally, there's an inversion. Create a buffer zone as necessary. Maybe you're doing an application and a neighbor's lawn is right next door. Leave a buffer line saying, hey, we don't want to apply pesticides on their property. They don't want pesticides, so we're going to leave a buffer. And then lastly, use drift control additives.